Okay. Hello, everyone. How you doing? Right. So I'm Kief Morris. I've probably my third time speaking here. I spoke here last year, and then like pre-pandemic, I spoke here at least once. So this is, as a lot of other speakers have been saying, this is one of my favorite conferences. So I'm really happy to be back again this year. A little bit about my background, I guess. I've been working with infrastructure as code since probably around 2001 or so. I started out using CF Engine and other kind of tools and all that, and then Chef Puppet and all the usual things. In 2016, I wrote the first edition of the book Infrastructure as Code with O'Reilly. Next month, the third edition is coming out, so it will be available. It's available now, pre-order on all fine bookstores and many bookstores that are not so fine and whose funding may go to uncool things, but anyways, wherever you like to buy books, you can buy a copy of that. I work for ThoughtWorks out of London, so I've been there about 15 years, and so I work with different kind of clients on this kind of stuff, infrastructure as code, and sometimes platforms and those sorts of things. So I want to talk today about kind of infrastructure as coding and automation in general, where that kind of falls in the value stream, and some of the issues I see with that. So one of the things I often run into at client organizations, infrastructure engineers, people who build infrastructure, they find that they're spending a lot of their time on kind of low value stuff, right? It's like there's a lot of toil and these kind of things. And then when you talk to the people who are using the infrastructure and the organizations who are kind of depending on it for things, they often say, well, we're often blocked. You know, it's kind of really slow to get stuff done and waiting for things to be done with infrastructure and all that. And I feel like if cloud infrastructure is a bottleneck, then we're doing it wrong, right? Because that's not what cloud was supposed to be about. So back in the day, we used to work with physical infrastructure. It was very inflexible. You know, we spent a lot of time setting it up, and it took a lot of time to kind of change things. And I wouldn't say we were that sad, actually. We kind of took it for granted. It was just like, that's what life was like. But cloud came along, and this was great because it was like, it virtualized everything, it wrapped an API around it, and suddenly you could get everything on demand when you wanted it. So rather than having to spend a week to get a new server set up maybe, now you could do it in minutes, if not seconds. And so that was really cool. And so then, of course, we brought in our automation tools, our infrastructure as code, and other kind of things, and we kind of reproduced the inflexibility of it. So it is just so common to see environments that are very static, right? So we use infrastructure as code, but it still takes a long time to make changes to it. We're still waiting a lot, environments are long-lived and all these kind of things, which feels messed up. And we've kind of maybe gone a little bit beyond that with cloud native, or there's an attempt to go beyond that of like, let's wrap another layer of APIs over on top of that stuff. But it's really messy. There's a lot of different kind of things going on there. It can be kind of confusing. And also, all that other stuff is still there, right? We're still like somebody's having to kind of build all this stuff underneath to create our wonderful engineering platform and developer experience and all that. So I feel like we're still kind of replicating a lot of the same kind of problems and issues. So, what happened, right? Why did this happen to us? One thing I would say is that we use the new tech to work in our old ways, the ways that we're comfortable working with. So we were comfortable with the idea that you have an environment, you build your QA environment, and it sits there for a long time, and people share it and clash with each other over it, and it gets polluted. And that's kind of like our comfort zone, right? And I think we kind of went back to that. And the way that we kind of developed the tools to automate everything kind of reinforced that way of working. So the thing about infrastructure as code, and even other kind of, how many people here saw Adam Jacobs' talk yesterday from System Initiative? Yeah, so I'm going to kind of refer to that a bit because obviously that's like really, it's really is kind of changing how we look at this stuff potentially. But with all these kind of new ways of doing things, we're still, I think that the starting point is often this kind of low level, right? So it's about, we've got a VPC, we put some subnets into it, network routes, and all these kind of things, and we wire them together. And so it requires kind of thinking at that low level. And this creates a gap between the people who are building the infrastructure, wiring things up at that low level, and the using of infrastructure, deploying applications, whatever it is that you're doing. And even if it's the same people, there is still that gap. There's kind of like a context gap. There's a distance between those things. So how do we handle this gap? And I'm going to talk about a couple of ways. So first of all is going to that coding paradigm thing, right? So The thing that kind of has come about in the past few years is this whole thing of, well, maybe the language is wrong, right? And I think you especially see this from software developers who look at infrastructure code, and it's like it's HCL, Terraform, Tofu type stuff, or maybe it's a lot of YAML and all that, and they look at it and it's like, oh, this is just what a mess, right? It should be a real programming language. And so there was this kind of like, CDK and Pulumi and these kind of things came out to say, let's address this, right? Let's use this to kind of address things. So the thing about declarative languages is that it really reflects how, like for me as somebody who's been a sysadmin for many years, like it reflects how I see things, right? It's like, you have servers, you have, networking constructs like VPCs and subnets and all of that. And so it lets you kind of define, here's my VPC, here's my subnet, here's how they connect together. And it's kind of, it's a very static view of the world, but that is kind of like my default view of the world. So it kind of reinforces, I think, that static view of systems. And so this, I think, has contributed a lot to how we build these kind of what I call snowflakes as code. In the old days before, when infrastructure as code was becoming popular, we talked a lot about snowflake servers that were hand-built and really hard to reproduce, and nobody was sure how they worked and all that. And I feel like, again, we've kind of reproduced that with code. So, okay, maybe we can reproduce it because we have the code, and maybe we can understand it because we can look at the code and see how it's built. But it is still like we end up kind of, every environment has its own copy of code often, and it's been customized and handcrafted, and people start working on a change. They're going to test something out in the QA environment here, and then get distracted and have to leave it. And so you end up with all your environments a little bit different from one another. So the idea of the imperative languages, and this is like, okay, it's like, hey, great, this is TypeScript. I know TypeScript, or JavaScript, or whatever it is. And so the idea is that I think the positive thing is it does make it more accessible, working with infrastructure more accessible to software developers. And I think that's a big part of its appeal. It doesn't necessarily close that infrastructure knowledge gap. And so this is that thing where you get developers looking at infrastructure code and they say, oh, this is just a bunch of YAML, and it's like, this is not a real language. Give me a real language and it'll be fine. And then they still tend to be in there with, okay, now I've got to understand the VPCs and subnets and network routes and all those kind of things. And so it still is like you still need that domain knowledge. And even if you have the knowledge, like you're comfortable writing software application code and you're comfortable with the kind of low-level infrastructure stuff, it is still a kind of a context switch that you have to kind of navigate. So it doesn't make that go away. Does it let us shift the infrastructure work onto developers and make life simpler? To some extent, maybe. I mean, maybe it avoids handovers. If you have the same people working on the software and the infrastructure code, then like they don't have to kind of hand over and ask somebody, can you change a thing for me? They can just do it themselves, right? But it doesn't reduce the effort that's needed. There's still the same amount of work there when you're working at that low level of infrastructure, as well as with the software. So you're either having software developers now splitting their time and saying, I'm going to take time away from focusing on my software and focus on the low-level infrastructure, or you set up a separate team who's using like a CDK or Pulumi or what have you, and they're an infrastructure team now, and they're working like developers, but you're still kind of back to the same amount of work going on and the potentially the same kind of frictions, I guess. One thing I do like about imperative languages is that it makes better sense for reusable components, which I think is an important way of getting away from all of this than static, declarative code. Again, if you're the idea of a reusable component is that it might behave differently or it might build infrastructure differently in different situations. And so it's useful to have a language that expresses that more cleanly. So also something thinking about, one of the things that kind of trips people up sometimes around infrastructure code, and especially when you get into the infrastructure code that uses the same language as software code, is there's actually a difference. And Adam touched on this yesterday. So applications, they run, when does an application code execute? Well, after you deploy it, and it's running there, and it does the things that the code that you wrote is doing the things in runtime. Infrastructure code executes when you deploy it. And it creates resources. And so that can be confusing, I think, because especially the other thing is that happens actually is that so before the likes of Terraform and these kinds of tools, a lot of us would write scripts to provision infrastructure in the early days of using kind of cloud APIs. So you might write, I used Ruby, people used Python, all these kind of things, and those were very much step by step, okay, create my VPC, now create these subnets attached to the VPC, create a server in the subnet, and you understood the order of events. Your code was executing the order of events. What happens with most infrastructure as code tools these days is that they're building a model, and this is true even with the likes of CDK and Pulumi and so on. So the code that you write is not step by step interacting with the API and carrying tasks out. So when you write, like, say, unit tests, this is one of the things that people love about these tools, is it's like, great, I can write unit tests now. I'm writing my infrastructure code as JavaScript, and I can write my unit tests in JavaScript. But what is a unit test testing, right? It's not testing the results. It's not testing the resources that you built. It's testing how the model is generated. Because again, your code is generating a model. That's what executes, not generating infrastructure. So that's kind of like, it's one of these things that you have to get your head around and can be confusing. And this is what is cool about the stuff that System Initiative, and there's a few other kind of ventures out there that are exploring this kind of post-infrastructure as code way of thinking about things, is can you take the model and can you have that kind of updated continuously, and can you interact with the model a bit more directly? That's really interesting. But I feel like we still potentially have that gap. So the first point when you're kind of looking at how am I building my infrastructure with whatever tool, whether it's a language, coding language, or whether it's modeling, working with a modeling tool and somehow interacting with the model, is that the first point is still those low-level resources, and how do you put those together? And so I think they're useful, and I think they can be part of making things a lot better, but I think we have to really think about what the problem is, because my fear is that we're going to use this new tech to work in the old way. So what can happen is you're still going to have people saying, oh, we need a new environment, or we need a change to environment. I'm going to deploy a new application. I need a database for it. And it's like, fine, raise a ticket with the team, the infrastructure team, the platform team. And they're going to use these really cool tools to kind of like, do all the kind of, model-based, modeling of infrastructure and really kind of cool stuff there, but it's still going to be those specialists doing it. You still have to wait for them to do it. And then the usual kind of loops of, and then they come back and say, great, I created your database. And it's like, oh, well, actually, it doesn't work quite the way I wanted. And you argue over, well, did you specify it correctly? Or is it, did blah, 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 blah. And it's like, that's not helping, right? That's where we already are. That's where we've been for a long time. So how else can we think about handling this gap in knowledge or gap in context? And so, the structure of the teams is a big, that's like kind of the obvious way to do it. In most larger organizations, this is where they go to, right? So if there's a gap in skills and all that, you set up different teams or what have you. So the way to think about it is like, who builds the environments that software delivery can happen on? So one option is you can have a full stack team, right? Again, you have your developers, they build their own infrastructure. And so that's kind of like low, no handovers. They don't have to wait on somebody else. They build, what they need to build, and the way they need it, they can debug the whole system, troubleshoot the whole system very easily themselves. And this often doesn't. I think the issue here is this often doesn't scale once you get into many, many teams, and everybody having to have, especially if what we're talking about is that low-level knowledge. So not talking here about using like a platform where somebody else has built, you're using a PaaS and somebody else has built the stuff for you. I'm talking about where you actually, full stack all the way down. So the most common thing that we see, and again in larger organizations, is what I'm calling an infrastructure management team. Now they might call it a platform team, but the reality is what happens here is that you have a separate team that manages the infrastructure on the behalf of the people who are using the infrastructure. And so again, it's that handover as the interaction mode. And this is the team topologies, if people are familiar with the team topologies way of kind of showing team structures. I'm drawing on that for these in their interaction modes. They talk about the undefined team type, which is not one of their kind of recommended ones, right? So you think about the kinds of infrastructure tasks that teams may need to have carried out for them. So there's like maybe changes to existing infrastructure, optimizations, adding new infrastructure, patching and updates, upgrading, creating new environments. Troubleshooting is another one where something goes wrong and you need help with what's down in there. So how can those things happen? And with this kind of, what I'm going to call it the infrastructure management team pattern or anti-pattern, and it's like, well, you ask somebody else to do it for you, and you spend a lot of time going back and forth. If you do kind of a value stream map across this, you see if you have like, let's say we need to add I'm going to deploy a new service and it needs a database instance, And so we've got to kind of do that in one environment after the other through the path to production. You end up with a lot of handovers, a lot of waiting, a lot of like, let's get it tweaked in this environment and get it working in that environment. So the third option is the infrastructure platform team, and I'm using the term platform, not necessarily, again, in how the teams are named. People name things however they want to name them. Organizations do things like that. But in the kind of team topology sense of the interaction mode here is as a service. And so the software team is able to get these things done with infrastructure in ways that aren't involving handovers. Now, to be clear, this isn't necessarily just like an API and platform as a service type of thing. It can be different things. It can be libraries and components, developer portals, web UIs. And some of these interactions can still be support and troubleshooting, right? So it's like if you have an API, if one team builds an API and then that lets me provision my own Kubernetes clusters, say, or my own database instances in ways that are kind of approved by my company and follow all of our policies and all that, they could still go to a team and say, oh, I need help troubleshooting, right? Or I need to understand, like I'm trying to kind of achieve something, I'm not quite sure how to do it. So it's not that it's not allowed to have the teams talking to each other, or that makes it not a platform team. It's just that that's not the default for most of the kind of business as usual type of activities. And then you have like enablement teams, which are kind of like it's kind of like a transitional kind of thing, where for some needs that are maybe new, that we haven't built services that are easy for somebody else to consume. We do have, we have the option to kind of say, well, we're going to kind of build something collaboratively, ideally, rather than having someone go away and build something and then see whether it's useful. And this can be scaled to multiple teams, right? You can have multiple, development teams. And in fact, this is where it starts becoming more useful, and where the kind of single team that owns the infrastructure and their software starts kind of struggling, is where you've got a lot of different application teams, and either they're all reinventing the same wheels, or they're kind of clashing with each other or whatnot. This is where it can be useful to kind of pull that out and have people, again, in a streamlined way, working on different aspects of the platform or of the infrastructure. So those kind of self-service interaction modes that I talked about, how can we create those? How do we get there? And I think ultimately, the core of kind of my point here is that I think we need to rethink the delivery model that we have for infrastructure, whether it's infrastructure as code or automation in some other way. So if you think about how software code is typically delivered, you build software, and then you have like a package with a version number on it, and then you deploy that across into different environments. With infrastructure code, that's kind of atypical, right? You tend to say, we're going to do that kind of build and deploy for each instance, and you may or may not have the same, code copied in, whether it's in branches or in folders, where you have separate copies of the code for every environment. You might reuse code. You might have modules to reuse code. But it's that act of, so how do you provision new infrastructure? How do you set up a new environment? Is that something that again is about working at the low-level infrastructure level, or is there an easier way to do that? So in other words, is it handovers where you're asking someone to do that for you and then hand it over to you and then do the little loop of, and that's not quite what I meant, or it's not working quite the way we need it to. I think what we need to move towards is more of building infrastructure code or automations or components or what have you once, and being able to deploy it to multiple environments like we do for software. And so that changes who can carry out different tasks and changes that thing to an as-a-service mode. And again, it's the same kind of tasks, right? And it might vary by task. So it might be that some things, and I think when thinking about this, thinking about, okay, how do we, how can we, change and work on how our organization works, how we're building infrastructure, how we're providing it so that things kind of work more smoothly for the people that use it. Not everything needs to be automated. Not everything needs to be an API. It depends how often does it happen. How often do you need to create a new environment? Now, on the flip side of that is if it becomes something that is more automatable and something that somebody can do on their own without needing to kind of build everything up from scratch, Suddenly you can do that a lot more often, you get a lot of benefits. So you can kind of create environments on demand or even just partial environments. I'm going to test my application component, just this one part of the overall system. Can I have a pipeline stage that automatically spins up just the environment that it needs, tests it, and then tears it down again, so that we're not having to kind of share environments and clash and wait for another team to finish doing, or troubleshoot something that turns out to be because somebody else deployed something into that environment we're trying to test in that broke something that we assumed was going to work differently. So, the more we can kind of go in this direction, the more kind of options it creates for more effective kind of delivery overall. So how can we do that? I think abstractions are an important thing for this. So again, referring back to Adam's talk yesterday with System Initiative, they talk about templates, right, which is a way of kind of bundling together components. I think an important thing is abstraction is not about limiting what users can do. And this is one of the pitfalls we often fall into with platforms and abstractions, whether it's libraries or anything, is trying to make it something where it stops people from doing bad things, stops them from having to know about things, which can affect the troubleshooting like we saw earlier. You need to be able to have visibility and understanding into the whole system. So it's really about the cognitive context. While I'm working on an application, and I'm working on the things of like, what is this thing supposed to be doing? I'm letting people kind of browse products and then put together a shopping cart and place an order and all that kind of stuff. While I'm thinking about that, I don't want to have to think about the details of network routing and all that kind of thing. But I might want to be able to. So in those troubleshooting situations, I might want to be able to switch, look at what is going on with the database, what is going on with the kind of connection pools and all that. You don't want to hide that from people. You don't want to say that like, we're gonna stop them from even looking at it. And I've been in those situations, right? I was in a client I was working at. It's a bank in the UK, and they had an early version of OpenShift. It was OpenShift 2, so pre-Kubernetes and all of that. And we were told, I was working with the software development team, and we were told we're going to use that. And so we would be deploying our application, and we would get an error code. This is kind of very early days, very early for them as well. So the deployment of the application would fail with a generic error code. And so we went to the PaaS team that was managing this OpenShift cluster. And we asked them, can you tell us what's going on here? And they said, we don't know. We don't have access to look at the logs on the servers. That's another team that has that. And so this is just one of those things where it's like, you need to create part of those interaction modes, I should say, is that kind of the visibility, call it observability, whatever you want. It's the ability to understand what's going on. And the more tools you can provide, the less often you necessarily need to ask somebody, can you go and figure this out for me? And the more you empower people to kind of at least figure out the first levels of, okay, it doesn't look like it's a database issue. It looks like it's it's an issue over here, or the further they can go with that, the better. So in terms of abstractions, there are a number of things, and I have a link at the end where I link to like some of the resources and things. There's one of the kind of areas that I find interesting of new infrastructure tools that are coming up are these things where, well, how do you put together multiple infrastructure projects and wire them together and have a way of configuring at that level? Most of what I've always done and seen people do is like we hand roll it, right? We have our shell scripts, our make files, our Python scripts, or whatever that we use to run the infrastructure tool, pull together the configuration parameters and kind of manage all that, and then manage the integration between multiple projects. If we have multiple, say, Terraform projects, each with their own state file, how do you kind of like wire them together in order when they run? There's tools, so rather than having to hand build all this stuff, there's tools out there these days which are helping to kind of standardize how we do that. And like I said, my links have some kind of pointers to some of those. But in a lot of cases, those tools are still kind of focused on, they're tools for infrastructure people, right? And so I saw this so I had a preview a little while back of HashiCorp's Stacks feature for Terraform, which is exactly this. And what I noticed was that it was still HCL. It was still like, I could not imagine a developer who didn't have deep infrastructure knowledge was going to use this, right? This was for an infrastructure person to accelerate how they work, which is nice. It's nice as an infrastructure person to be able to get things done more easily, but it doesn't help close that gap. So what I think we should really be focusing on, and some of these tools are going to go in this direction or are based on this idea, but I would call it infrastructure products. And this is just the idea of yeah, it puts together different bits of infrastructure, components, projects, modules, whatever they might be, and wires them together for you, but just designed in a way that's accessible for developers. And again, not closing things off, not so that they can't go deeper down. And also, by the way, those two, I've got these kind of two green and purple sets of people. Those may be the same people, right? It just may be, again, people shifting their context. Okay, I'm thinking about my application. My application needs a database. What do I care about at that level, right? So these things should be thinking about as somebody deploying an application or specifying what an application needs, what do I care about? Well, is it going to have personal data? Maybe I need to care about that. Is it going to have other kind of sensitive things, medical records or what have you? So maybe I just need to specify that level of thing. Is it transactional? Is it for analytical? Those kind of purposes. And then the code works out, okay, what's the right thing to put in place for those then? And if it's not right, if my needs aren't met, then I can shift the context and look into, well, how can I build a thing that is more suitable to my needs? So yeah, I think that kind of summary really is just, I think we need to focus infrastructure building. I think we need to think first about what the outcomes are that we're looking to get for infrastructure users. And it's not that like anybody, I think, would say, well, we don't care about those, we just care about the infrastructure, and it's not an end in itself. But I think it's that, where do you start? Yeah, my mic is gone. This one? I'll just shout. I'm almost done. I'm wrapping up. So I think it's just the first. I think we need to start with, okay, what does our organization need from infrastructure? What do the users who are deploying things on it and using it for different things, what do they need from the infrastructure? What outcomes do they need? And then, and then optimize for that. And I think all the kind of cool tools and better ways of doing things, I think we need to do those with that in mind. So thanks. I've got links and all that here, and appreciate it.